I'm Mike Engelson. I'm the Executive Director of Wisconsin Lakes, the statewide organization of lake organizations and lake advocates. Welcome to this session. We have two sessions in this time slot, actually an overview of impacts of motorized watercraft on Wisconsin lakes and wave propagation dynamics and water quality impacts on a freshwater lake in southeast Wisconsin, that being North Lake in Waukesha County. I have seen all of our presenters talk. I think this is going to be some really interesting stuff about wave dynamics and the impacts of wakes on our lakes, especially from the larger watercraft that we see more prevalent these days. Just a few housekeeping notes to start out. Of course, if you've been doing this for a while now, for the last 2 days, you probably are used to this. But if you have questions, please type them into the Q&A, not the chat. We can see the Q&A, but we can't see the chat. And I'll pass those questions on as they come along. We'll have a chance to ask Tim Asplund a couple of questions at the end of his session, and then hopefully there'll be time at the end to have a roundtable discussion with everyone. And you can always interact with the presenters through the EventMobi platform as well. You just find their name in the speaker or attendee list, click and send them a message, and they'll be able to interact with you that way as well. So our first presentation is from Tim Asplund. Tim's currently the chief of the water quality monitoring section for Wisconsin Department of Natural Resources. He's been with DNR for 27 years and has been involved in lake monitoring and research throughout that career. He tells me that motorboat impacts is what he, quote, cut his teeth on as a new researcher with DNR in 1994, and the rest is history. So Tim, take it away.
Great, thank you, Mike. Just want to make sure this is all doing what's supposed to do here. You see that okay?
Yep.
Great. Well, thanks. And thanks for the opportunity to present today. This is definitely something that near and dear to my heart. As Mike said, when I first started as a researcher with DNR in 1994, this was an issue that a lot of people had questions about and were interested in. And my boss at the time sort of said, here's a project for you. You start putting together some research on it. And so what I'm going to do today, and that kind of culminated in about 2000 when I moved on to another job within DNR, but I had put together a summary paper and a literature review by that point. And, you know, I get questions on that paper still to this day. Every year, I probably answer 4 or 5 questions, emails, people working through these issues. It's sort of there's sort of a timeless element, I guess. You know, some of the information that I was able to put together is fortunately still being used and helpful to people. So what I wanted to do is just give a real high-level overview of some of the things that I looked into and some of the summary conclusions that I came to, and kind of dig in a couple of the projects that I was involved in, but then really kind of turn it over then to the next presenters who are going to really give you much more updated information and hot topic kind of information. So hopefully the two presentations will work together well. So, you know, you're thinking about boat impacts, you know, there's a variety of things that this could come to mind, you know, from engine pollution, from gasoline powered motors, outboards, leakage or exhaust issues, spitting up turbidity or sediments from propellers, shoreline erosion from waves, to aquatic plant effects to propellers. You know, all those things come to mind. You know, we know that boats are vectors for aquatic invasive species, noise impacts, things like just where we put our boats even can have some detrimental impacts sometimes. And I was involved in some studies looking at the effects of these multi-scale piers on the nearshore habitat. So, you know, there's a variety of different kinds of impacts that you can think of when you think about motorized watercraft. But there's also a whole other thing, and as the other speakers will probably attest to, a lot of this comes down to just user conflicts also, just whether there's incompatible uses or things that are, you know, people like quiet water sports, people like the race boats, we do both at the same time? Probably not. So how do we work those kinds of things out? But also crowding. This is kind of, sometimes just more and more people enjoying our lakes, and then that can create user conflicts, but also these questions about ecological impacts. And sometimes it's just sort of certain activities, I know when I started, everybody was there, or a lot of people really were upset about jet skis and, convinced that they were having ecological impacts. But in terms of regulating activity, and there's some things that we can't really do just to, it's really more how some of these watercraft are used or where they're used rather than the actual user themselves. That's the problem, or the type of watercraft. And so that's been an important part of this, is just sort of weaving through the ecological impacts and trying to separate those out from things that are more social kind of impacts, and coming up with some ways and compromises, and how do we allow for a wide range of recreational activity on waters, but also do it appropriately so we're not creating ecological harm. So that was kind of the milieu that my research was in. So again, I sort of put this table together to summarize the kinds of things and help kind of focus the kinds of things. It seemed to me, or what I was hearing most, were people were concerned about things related to water quality and water clarity and turbulence, and turbidity, shoreline erosion, and effects on nearshore habitat. And so those are the things I focused on, and then really zeroed in on kind of the mechanisms like direct propeller or hull contact with sediments or plants, turbulence created by the propeller or the prop or the waves, and then the waves in the wake themselves. And so what I'm going to do is just sort of go through and summarize a few thoughts on those topics. This is one of my, again, grainy photos that I have from my collection. I apologize for that, and it's kind of an odd one because it's got this biplane kind of in the front view, but but what you can see behind that is, here's a lake. I don't know which lake this is exactly, but it's got a lot of boats on it. You can actually see the turbidity being created in this lake with all the boat activity, and you can track the different boats. So this was something that people were aware of and concerned about, and one of the things that I was asked to kind of look into. And again, it's not surprising that if you have a motorboat that goes through a very shallow water area, you're going to turn up sediment, and that's going to potentially create some concerns or some issues. One of the interesting things that I've found, though, and kind of supported by the literature, that this isn't necessarily correlated with boat speed. So in other words, not necessarily the faster boats that are causing the more issue, but it really is sort of this transition speed where that thrust activity is pointed downward the most, that has the most impact. And plus it's also really dependent on the depth of the water. So obviously in deep water in the middle of the lake, you're not going to have that sediment disturbance. In the nearshore area, where it's a few feet of water, that's where you're going to have the more impacts. So it's really this zone. I don't know if you can see my cursor, but it's this zone here, which is where the moderate speeds of the boats, and it's also where the shallower water. So that's where you're going to see the most disturbance at the bottom of the lake, and that's the place where you're going to have the most potential for impacts. So one of the projects, this is sort of jumping up a few years. This was sort of after I had been actively working on this, but there was a study done up on Clark Lake in Door County by a fellow named Darren Hoverson, who now works in Minnesota for Minnesota DNR. But he went out and did some trials, and I helped him out and set this up, where we tried some different motorboat types. We had pontoon boat, jet ski, 100 horsepower outboard motor, and then 160 horsepower inboard outboard motor. And we basically just had those folks, we had some volunteers from the lake, and they drove past some water sensors we had in the water column and at different depths. And what we found is that, what you can generally see here, and again, there's a lot of data, but just at a high level, what you see is at 4-foot water depth, you see much more impact, more turbidity or suspended solids being created than you do at 6 feet, which is just kind of common sense. But you also see these early charts, or these early bars, are the slower speeds, that startup speed. So the highest bars here are obviously the biggest motors. And what we see is even pontoon boats at the startup time can have detrimental impacts even at 6 feet water depth. So but the point here is that if at no wake, there's no real impact on this sediment, but the bigger the boat, the motor, the draft of the boat, the more likely it will resuspend sediment. Pretty much common sense, but it's nice to see the data support that. And then boats operating at shallow water depth were more likely to resuspend sediment. And then it's really this startup time, or where the angle of the boat before a boat gets up on plane speed, where you see the most impact and most sediment disturbance. And this was supported in some other studies. This was a study done in the Fox River chain of lakes in northern Illinois. What you can see here is this has to do with boat traffic in some of those channels between connecting lakes. And what you see is that at shallow depths, like 3 feet depth, with more boats, you get more turbidity being suspended over time. When it's 6 foot deep in marl or silt, it takes more boats to generate that kind of level of suspended solids. At 8 foot depth, though, for silt and marl both, you really didn't have any increase. And so it really is, it's the depth of the water that really matters ultimately. And then you can start to look at things like boat size and other things too, and numbers of boats in terms of impact. So the thing that I got involved in then is thinking about these mechanisms. We sort of went out and said, was this a problem on lakes generally in Wisconsin? So we enlisted volunteers, and they went out faithfully and recorded Secchi disc readings and boat counts on weekends, summer weekends throughout the summer, and compared water clarity on weekdays and weekends, and then looked at near shore versus mid lake. And what we saw was generally what you see here is if there was no change, you would expect then everything to fall in this 1-to-1 line if there's no change between weekend and weekday. But what you see is each of these points scattered here, if you draw a line through it, what we found was that indeed that basically the lakes that were clear on weekdays tended to be less clear on weekends. And so this was, and some of these were there was a big difference, between water clarity. So it's definitely a noticeable impact on water clarity in some of these lakes, especially clearer lakes. Down here, you could see if it was already turbid on a weekday, it's not going to get any more turbid on the weekend. So if you already had a lot of algae, if you're a eutrophic lake, it's probably not going to be that much measurable. So it's really, the impact is maybe more noticeable in these clear lake systems. And then we kind of went in and did this a little bit further, not just water clarity, but we actually collected some data on about 10 lakes. And what this sort of just summary slide here, again, so these patterns, shallow, this is a difference between the weekday to weekend change. And what you see is that water clarity, what this means is there was a half of a meter, or about 2 feet, maybe 1.5 feet difference in water clarity. The difference on shallow lakes was much more dramatic than it was on deeper lakes. Same with turbidity. You got a lot more turbidity on the weekends on shallow lakes than the deep lakes, as well as phosphorus generation. So again, it's very measurable. It's something that can happen if you got a significant number of boats operating in a shallow area, where that prop can hit the turbulence can hit the bottom. It can actually have water quality impacts on lakes. And this sort of just, again, supported, we went out holiday weekends. And again, the deeper the lake, the less impact that we saw in the near shore area. So shallow lakes really, or shallow areas of lakes, are really where we saw the problem. The other thing we looked into kind of related to prop impacts was impacts on aquatic plants, in some possible mechanisms, just propeller damage to the rooted plants, uprooting of those whole plants if that turbulence is hitting the bottom. Suspending the sediment or substrate disturbance can shade out plants or potentially limit light, or just the wave stress, just moving back and forth, can potentially have some detrimental impacts. So we set up kind of here's just another anecdotal, observation of a boat tracks, being observable through some carra beds. So we did this kind of really cool study where we set up some enclosures in a nearshore area on this was Lake Ripley near Cambridge. And you can kind of make it out here. It's a little grainy again, I'm sorry. But what we did is we had two different enclosures we set up. One had solid plastic walls. The other had mesh walls, basically construction fencing, the orange construction fencing. The idea was, well, let's exclude boats from these areas, but have one where turbidity could affect plants and the other one where turbidity wouldn't affect the plants, and seeing if we can figure out if there's any impact on the plant community. What's interesting is this photo was taken toward the end of the study. You can actually see there's a big ring here of darker area, whereas out here, this is all barren, and you got tracks, boat tracks, all the way through around this area. So basically, people avoided this whole area just because we had those enclosures out. And we saw that respond in the plants. Both enclosures had much more biomass, plant biomass, than in the areas outside of those enclosures. And there really wasn't any difference between the mesh or solid enclosures. So it was really the direct disturbance of the plants that was the issue, not anything related to turbidity. So we extended this to kind of say, well, can we do something about this? And so we worked with folks up in Long Lake and Fond du Lac County, and did some experimental things. We had an area in 1995 where you could see, this is just an aerial photo. This shows the shallow shelf, and this is deeper water. What you can see is that there's a lot of barren boat swipes through this area. In 1997, we put some buoys out along this area and had a voluntary no wake zone in place. And lo and behold, there's no scarring of the plant community, just because people avoided this area. They didn't drive over, they drove over here in the deeper water. And then the next year, the buoys were moved in towards shore. And again, we saw that the scarring start to happen again. So some visual evidence, again, that just simply through some no wake zones to protect those shallow nearshore habitat, that's actually very effective. This was in place even without any necessarily enforcement. It was just voluntary. It had maps. We asked the people locally, asked people through education to avoid these areas, and these were sensitive areas for fish and plants, and it worked. So it's kind of a cool little project. So the last thing I'm going to just kind of touch on, but our next presenters I think will go into more detail, is the idea of boat waves themselves and wake. And I know that's a big concern right now, especially with the wakeboarding kinds of activities. But one thing I'll say again, this idea of, the issue for even wake is also related to this kind of transitional speed zone. And it's the time between where you have the boat is starting to start up and it's displacing more and more water. It reaches this peak wave height threshold at this semi-planing speed. As the boat gets faster and faster, it actually, the wakes thrown off by it are less. And so the issue is where those boats are either intentionally or creating that maximum displacement, or in that zone between no wake and planing where the biggest waves occur. And that's where those are the things we would need to manage if there's concerns about erosion. So some studies, again, this is related to boat size. Here's just some work that was done in Minnesota showing that wake heights that are reaching the shoreline are much higher, obviously, in that 0 to 100 foot range than they are in the 100 to 300 foot range. Beyond 300 to 500 feet, you really don't see very high waves reaching the shoreline. However, the large cruisers there in this study still did have some measurable higher, effects. So the bigger the boat, the further out from shore you would need to be to sort of minimize those boat wakes reaching the shoreline. They also did a study here on the St. Croix River, the Minnesota folks. Kind of really, well, does this matter? What level do waves start to actually create erosion? And again, what they at the smaller waves, you don't really see much sediment mobilized, but there is this sort of threshold of sediment mobilization that occurs at about a half of a foot. And then as you get closer to 1 foot height, that's where you can actually see a lot of sediment or bank erosion start to occur. So definitely, to manage this, you want to keep boats further away from shoreline as you can to be able to kind of minimize any kind of boat-induced shoreline erosion. And again, it has to do with this velocity issue as well. This is some data that they collected in sediment traps, and they related and saw much more mobilization of sediment when those boats were at these kind of transitional speeds than they did when they were at the higher speeds. And so again, my conclusion from a lot of this was no wake zones are really helpful to protect shoreline erosion, to protect nearshore habitat. It's one of the reasons why we now have a 100 foot from shore minimum rule for watercraft, and 200 feet for jet skis. But I think, unfortunately, there may be cases, not all lakes are created equal. We have plenty of lakes where we have shallow water well beyond 100 feet from shore. There are places where 100 feet may not be enough to protect against some of the impacts along shoreline. And so I know a lot of times that comes down to the local community having to enact their own ordinances and tailor those ordinances to a specific lake. So I'm just going to wrap it up. Boat wakes contribute to shoreline erosion, especially in areas protected from wind energy. But there are other factors that cause erosion as well. Prop disturbance is greatest at shallow depths or in areas with aquatic vegetation. 10 feet is kind of a rule of thumb, but it can certainly be, certainly 4 feet is much more impact than 6 feet or 8 feet, but 10 feet is a kind of a rule of thumb. Beyond 10 feet, you're really probably not going to get much sediment disturbance from boat props, excuse me. And then last to this, I think this is really important, is this maximum impacts occur at these transition speeds of the boats. When they're going from a no wake speed to maximum displacement to getting up on plane. That's really the critical zone for both sediment disturbance as well as wakes. And but obviously a lot of variables there that play into account. So I know I kind of sped through that, but I want to give plenty of time for the other presenters. So I'll leave it there. Thank you.
Thanks, Tim. And I think we got some time for just a couple of quick questions. One that really seems to have come through in the Q&As. Do you have any way of considering how many boats are too many for a lake? Have you looked into that at all?
Yeah, so that's kind of this idea of carrying capacity. And I've not done it myself, but I know there was some work on Lake Ripley, actually. Paul Dearlove, when he was the lake manager down there many years ago, they did a really nice study looking at capacity limits. And it does, you can do that based on some of these rules of thumb. And I know people have done that. Looking at your lake size, your shape, the morphology. So mapping out the shallow zone, if you kind of determine where the 10-foot depth zone is, and then also impose your 100-foot from shore no wake area. That way you take into account any kind of variables on the shoreline or channels. You can actually map out then what is the available space for safe boating, for example. And then you can, there are you can kind of look at density. There are some estimates out there about how many boats per acre is sort of a reasonable number, so that people don't perceive crowding, or there's adequate space for water skiing. And so you can do that analysis too, and then come up with a carrying capacity, like an optimum number of boats at any one time and where they would operate. Great.
And one more quick one. There's some other great questions on here, but I'm going to try to save those maybe for the end, because I think they may play into some of what's talked about in the next presentation too. But Tim, does the chemical characteristic of sediment affect how much phosphorus is released into the water column?
Yeah, definitely. That's actually the very first study that I did. We actually did some sediment cores where we looked at the different release of phosphorus based on different sediment types. So yes, definitely. So more calcium rich marl type sediments actually bind up phosphorus much more tightly. And so then you might get the turbidity, but you don't get the phosphorus release. Whereas more loosely bound iron or organic sediments, mucky sediments, those can actually release their phosphorus much more easily than others. So that definitely is a factor.
Great. Well, thank you so much for that sort of grounding in the basics.